So, dear students, here I've written down those formulas that I just told you are important. Chief formulas used in the chapter of force, class 10. So, first formula is F equals to G m1 m2 by d square. This is the formula to calculate the force, not anything else. This formula is there. There are two formulas. When the radius is only given, you use this one. When the height is given, you add the height to the radius and square it. And this formula is used in calculating the acceleration due to gravity of a planet. And next is weight formula. Weight is what calculate the weight of a body is usual question that is asked in your examination as well as in your exercises. So weight is m into g. M is the mass of the object and g is the acceleration due to gravity of the planet you are talking about. So last formula is g dash by g equals to r square by r plus h whole square, where g dash is acceleration due to gravity at certain height from the earth's surface. G is the acceleration due to gravity at the surface of earth, that is 9.8 meter per second square, which is usual value. R is the radius of earth. Here r is also radius of earth, but h is the height at which that object is kept from the earth. So sometimes instead of giving these two separate values, radius, instead of giving the separate radius of a heavenly body and height of the heavenly body, directly the question gives distance from the center of the earth to the heavenly body. In that case, you don't need to use r plus h, just use d square. You consider this r plus h to be d and use the formula. So these were the formulas that are some basic formulas that are used in this chapter. So I have written down a question that will tell you how to do the problems related to this question. G dash by g equals to r square by r plus h whole square. So such questions use this formula. The question that I have written down is a usual question that is you can find in any books. Might be the pattern might change, but they are usually the same. So calculate the acceleration due to gravity at the top of the Mount Everest. We need to calculate the value of g at the top of the Mount Everest. If the acceleration due to gravity at the earth at surface is 9.8 meter per second square and the radius of earth is 6400 kilometer. So if you look at this question, there is nothing talked about the mass, there is nothing talked about other values. There is only two values given to you. One is the three values given to you. One is the acceleration due to gravity at the surface of the earth, that is 9.8. Next, there is given radius of earth r 6400 kilometer, and next height of the Everest is given 8814 meter. So we'll be using these values and finding the value of the acceleration due to gravity at top of the Mount Everest now. So let's begin. So solution, first let's calculate the given, let's write down the given values to values. So first value given is acceleration due to gravity at surface. Let's write that down. So acceleration due to gravity at the surface is always represented by small g. There is no g dash. So g is 9.8 meter per second square. So this is the value of acceleration due to gravity at the surface. Next is radius of earth. Since earth is a heavenly body, so radius of earth is given by capital R and its value is 6400 kilometer. Cannot do calculation in kilometers, so in convert into meter. 6400 into 1000 meter, that is 6400000 meter. So next we are given is the height of the Everest. H is given 8848 meters. Now let's use the formula. What we need is acceleration due to gravity top of Everest. So top of Everest means it is at certain height, 8848 meter height. Now we need to calculate that z dash at that height. what? We don't have that value. So z dash is to be calculated. Now let's use the formula. Z dash by g is equals to r square by r plus h whole square. So we need the value of z dash, so let's keep the values. Z dash is not given, g is given 9.8, r square is given 6400000 whole square. So radius 6400000 plus height is 8848 meter whole square. So we kept the values. Now we need this z dash, so z dash sits on the right hand sides and other goes on the left hand side. So 6400000 whole square by 6400000 plus 8848 whole square into 9.8 goes here, 9.8. So let's calculate the values and write it down. So the value comes 0.997 into 9.8. So you get 9.77 meter per second square. So you can see as the height increases from the Earth's surface, the value of acceleration due to gravity decreases, and that you can observe from this value. At surface it is 9.8 meter per second square, and at top of the Mount Everest it is 9.77. So this is the problem related to the last formula that we use, z dash by g equals to r square by r plus h whole square.